Okay, good day, everyone. I will discuss to you now our second handout, which is all about polygons. Okay, so definition. A polygon is a two-dimensional closed figure bounded by straight line segments. So it is a closed space bounded by line segments. The term polygon is a combination of two Greek words, poly, which means many, and gonia, which means angle. Then we have here the parts of a polygon. The side or the edge is one of the line segments that make up the polygon. So for this, we have this diagram. So the side or edge kuno is one of the line segments that make up the polygon. So in this case, or in this illustration, we have this side. So this is one side, and then another side. Okay, we have that one. A vertex is a point where the sides meet. So this is an example of a vertex of this polygon. So that side and this side meet at this vertex. So we have how many vertices in this polygon? We have 1, 2, 3, 4, and 5. Diagonal is a line connecting two non-adjacent vertices. So this is our vertex 1, this is our vertex 2. Ang diagonal kuno is again a line connecting two non-adjacent vertices. So this is an example of the diagonal. We have that vertex to this vertex. That is its diagonal. Another one we have from that vertex to here. Wait. Okay, it's not that straight. Okay. Interior angle is the angle formed by two adjacent sides inside the polygon. So this is your interior angle. So this side and this side. So from that to this is your interior angle, this one. Or kinesia. It's interior angle. Exterior angle is the angle formed by two adjacent sides outside the polygon. So this is your exterior angle. If we try to extend this side right here, kinesia side, if we extend this one, we have this side. This is your exterior angle outside of the polygon na. Apothem of a regular polygon is the segment connecting the center of a polygon to the midpoint of a side. The apothem is a perpendicular bisector of the opposite side. So if this is the center of this regular polygon, your apothem is a drop or a segment na siya from the center to the midpoint of a side. So for example, this is an apothem, this one. Or for this side, we have this apothem. So, kinesia apothem, it is perpendicular to this side. Central angle of a regular polygon is the angle subtended by a side about the center. So, this is a central angle. This one. From the vertex to the center, and then kinesiang angle. Okay. So, three major characteristics of a polygon. It must be a two-dimensional figure. So, two-dimensional figure lang ang polygon. So, it's not three-dimensional. So, ang unit na to for like area and perimeter of a polygon is in square units. Square units. A polygon must be a closed figure. So, third, it should be bounded by 3 or more straight lines. So, in this first set of figures, kani silang tulo, these are not a polygon, while kinesia, so these are examples of a polygon. So, it has the three major characteristics of a polygon. Polygons are said to be similar if their corresponding interior angles are equal and their corresponding sides are proportional. So, we will now have the similar polygons. They are of the same shape but not necessarily of the same size. So, for example, let us have similar polygons, rectangle lang ha. I'm sorry, but it's not perfect. So, not necessarily that they are equal. So, not necessarily equal siya, but it's proportional lang. Proportional. Ay, tingali ka na lang. And we have here ang iyaha ko nung corresponding interior angles are equal. So, in this case, since I've drawn a rectangle, so you could really say that one side is 90. So, kana siya corresponding angles niya are equal. Or kung kintahay triangle class, we have a small triangle. So, for this and this, it must be equal para mas-similar na sila kani and this one and this and this. And then, ang iyang sides must be proportional. So, you have here the following relations between two polygons obtained using the concept of ratio and proportion. So, when we have similar polygons, let us try to see if these following relations are true to any set of similar polygons. The ratio of any two corresponding sides of similar polygons are equal. So say for example, this is our first polygon. This is our A2. And then the measure of each side x1 is, shall we say, 2. And then iyahang y1 is 4. And let's have this x2. This is 4. So, dapat proportional man siya class. So, 2 and 4 and 4 and let us say 8. Equal ko no. The ratio of any two corresponding sides of similar polygons are equal. So, x1 over x2, it should be equal to y1 and y1 over y2. So, let us say your x1 is 2 over your x2, which is 4, is 2. Your y1 is, in our figure, 4 over our y2 in our figure is 8. So, if we try to simplify, this is 1/2 is equal to 4 over 8 is also 1/2. So, they are equal. Next relation. The ratio of the areas of similar polygons is the square of the ratio of any two corresponding sides. So let us try to check this one. So A1 over A2 kono is equal to x1 over x2 squared. So for A1, our A1, ang area niya is 2 times 4. So area of a rectangle. Over A2, area sa second polygon nato is length times the width. So 4 times 8. x1 nato class is 2 over your x2 is 4. And square. Now, kung ato ni siyang i-simplify, if we simplify this is 8 over 32 is equal to, this is 2 squared is 4 over 16. In which case, 8 over 32 is 1/4. And then 4 over 16 is also 1/4. So check. So this is really applicable. this relation is true to a similar set of similar polygons. And then lastly, the ratio of the perimeters of similar polygons is equal to the ratio of any corresponding sides. So perimeter for the first, I can see. Perimeter for the first, since we have a rectangle, so perimeter 1 na to, if you remember, that is 2 times 2 plus because niya side is 4 times 2. And perimeter of the second, katong larger na itong rectangle, it's 4 times 2 sides nga 4 plus duha ka sides nga 8, right? Then x1, ano siya itong x1? Atong x1 is 2, atong x2 is 4. x1 is 2, x2 na to is 4. So this is 4 plus 8, 12 over 8 plus 16, 24 over 2 fourths. So 12 over 24 is 1/2. 2 over 4 is also 1/2. So check. So this is another relation between a set of similar polygons. We have the types of polygons. So let us see. Simple and complex polygons. So this is an example of a simple polygon. Only one boundary and the sides do not cross each other. Otherwise, it is a complex polygon. So as you can see, ang sides niya nag-intersect, nag-cross na sila. Concave and convex. A convex polygon has no internal angle more than 180 degrees, and if there are any internal angles greater than a straight line, then it is a concave polygon. So this one is an example of a concave polygon. Naa siya'y reflex angle. And ang internal angle that is more than 180, more than a straight line. Then a convex, so kanisiya, this is an example of a convex polygon. Next, regular and irregular polygons. Regular polygon is one whose sides are all equal and whose interior angles are all congruent. So this is an example of a regular polygon. So iyahang internal angles are equal. So when we say congruent, those are equal. And then iyahang sides pod equal in length. A regular polygon is both equilateral and equiangular. Equilateral meaning iyahang sides are all equal, and when we say equiangular, all internal angles are of equal measurement. Otherwise, so if not, that polygon is said to be irregular. Like for example, this one, lahi-lahi na siyang angle, no? This, and also the length. So it is, if it is not equiangular and equilateral, that is an irregular polygon. So we have here the names of polygons. The polygons are named according to their number of sides. A polygon with n sides is called n-gon. So we are familiar already with the triangle, a polygon with 3 sides. This is not a polygon. Okay. So we have here, I hope you'll just familiarize with it. You familiarize these names. 10-sided polygon is a decagon. We have 50, pentacontagon. Icosagon, 20 sides. Triacontagon, 30. We have 400-sided polygon, that is hectagon. And 10 to the power 100 sided nga polygon, that is googlegon. Okay. Formulas in polygons. So these formulas, since this is already proven mathematically, so we'll simply have to familiarize these formulas so that in solving problems involving polygons, if we know the formula, so it is simply direct substitution class. Kung kibaw lang ka sa formula, easy ra kayo ang problem. So direct substitution ra ka. Perimeter, so we will I will just show to you a very quick discussion of the formulas that we have. Perimeter is the length around the boundary of a closed two-dimensional region. The perimeter of a regular polygon is given by the formula P is equal to S times N. So the S is the measure of one side and N is the measure of the number of sides. Area is the amount of material that would be needed to cover the surface completely. So sa kalahian o perimeter area. Say for example, you have a square. Ang perimeter class is this. The sum of this, kana, kana, kana. The length around the boundary. This one, this, and plus this. While ang area is the amount of material that would needed to completely cover the surface. So, kani siya. Kana siya. Mao na ang area. Okay, it is given by the formula S over 2 times N times A. This is the side one, the measurement of one side over 2 times the number of sides, and then A is the apothem, the measure of your apothem. The area of a regular polygon with an apothem is given by, okay, regular, if it is a regular polygon, we will use this 1/2 PA, 1/2 times the perimeter times the apothem. Or, we can have this formula, S squared. S is again the measurement of one side, squared, times N is the number of sides over 4, cotangent 180 over N. N is the number of sides. And by the way, how do you get cotangent when you try to calculate it using a calculator? Cotangent class is simply 1 over tangent. So, kung kaning cotangent 180 over N, that is simply, so ini-calculate ni mo ana, that is S squared times N over 4, and then 1 over tangent of 180 over N. So, ninaon mo pag-calculate. Okay. A regular polygon can be subdivided into congruent isosceles triangles whose common vertex lies at the center of the polygon. Okay. Kung regular polygon, say for example, we have this one. A regular polygon can be subdivided into two congruent angles. So from the center to the vertex. So we have created isosceles triangles. So 1, 2, 3, 4, 5, 6 ka isosceles triangles. So ang area kuno niya is equal to the total area of the polygon is area of one triangle times the number of sides. So isa ka triangle times pila ka sides, 1, 2, 3, 4, 5, 6. That is now the area of the polygon. Regular polygon. Number of diagonals in a polygon. So unsa man ang diagonal? Kani siya ng diagonal, mao ni siya, di ba? So, it is given by the formula n over 2 times n minus 3. So, n is the number of sides. So, say for example, we have 1, 2, 3, 4, 5, 6. So, 6 ni. So, 6 over 2, 6 minus 3. This is 3 times 3. This is 9. So, pila. So, you can, that is the number of diagonals in a polygon. This one, lahi sa ni siya. So, kani, this is the number of triangles formed by diagonals drawn through the same vertex. So, kani siyang, this one class, number of triangles, dahil ni siya. Okay. Say for example, from this vertex, magdraw ka og diagonal. Kani siya nga diagonal. So, we have 3 ka-diagonals. So, pila man kuno ka-triangle ang atong na-create. So, for this, di ba, ato ang n ani is 6 minus 2. So, 4. So, sakto ba? Nakakreate ba tag 4 ka triangles? So, 1, 2, 3, 4. So, sakto 4 ka triangles. So, mo na gimin ani. Central angle in a regular polygon. So, central angle is this. So, kani siya. Center sa imuhang polygon. And then, kani siyang angle. That is a central angle. So, for a regular polygon, if ani ka sa center, this one, kani siya is 360 degrees, right? So, kung i-divide ra na natog pila ka number of sides, mo na siya angle sa central, mo na siya measurement sa central angle since regular polygon man siya. So, we will simply divide 360 divided by the number of sides. Then, each interior angle of a regular polygon, so each interior angle ko no, so this one. So, kana, this measurement right here, this. So, since for a regular polygon, ang interior angles are all equal, so you have to follow this formula. So, n minus 2 over n is the number of sides, then multiply by 180 degrees. And then, sum of interior angles, so, kani siya, the measurement ni siya sa isa ka interior angle. Then, if we try to get the sum, we have this formula. So, kung ato pag kuno i-add tanan nga measure, no? Sa interior angle, ana. This is given by the formula n minus 2 times 180. N, again, is the number of sides. Okay? So, now we will proceed to the sample problems.